One of the great advantages of using variables rather than just numbers is that we can manipulate them and we can compute with them. So we can use regular good old arithmetic to create new variables from old ones. Let me show you what I mean. The basic things we can do are our old friends from our four-function calculator. We can add two variables together using plus. We can subtract them using minus. Now notice this isn't the underscore. This is actually the minus character. We can multiply them. We use the star for that. And we can divide them by using the slash. Now, if we want to do more than one of these things at once, we have to tell the computer what order we want them to come in. And to do that, we use parentheses. And we always use the round parentheses. Whenever we do this kind of little math operations with variables, we only use the round parens. There are lots of pairs of characters on your keyboard. There are square brackets and curly braces, but we only use the round parentheses. So let's look at how we might use these to manipulate our variables. Let's suppose we're keeping a little fruit stand and we have a bowl of grapes, and we want to track how many grapes we have. So we'll create an integer called numGrapes, and we'll give it the value 20. We'll assume that there's 20 grapes in here. Now we double the number of grapes because we get a second identical bowl of grapes. How many grapes do we have now? Well, we just reassign into numGrapes the value numGrapes times 2. When processing sees this, it evaluates the right-hand side first. It looks at numGrapes times 2, and it says, well, numGrapes is currently 20, so I compute 20 times 2, or 40, and I stick that into numGrapes. And now numGrapes has the value 40, because we have 40 grapes. Now suppose we add one more grape. What do we want to do? We want to add 1, so we just do it. We say numGrapes equals numGrapes plus 1. And it says, well, the current value now is 40. I add 1, that makes it 41, and I stick 41 into numGrapes. And in this way, we can manipulate numGrapes over time, adding to it, removing from it, multiplying, dividing, to change its value as we change our inventory of grapes. When we do more than one thing, we need to use parentheses, as I mentioned before. Let's see why. Suppose that you write this little expression. Now, you had something in mind when you typed this. You either meant to add 2 and 3 and then multiply the result by 2, or you meant to multiply 3 and 2 and add 2 to the result. It turns out that those are completely different answers, and let's see why. Suppose that we do the plus first. So I'll explicitly put a pair of parens around it. So I have 2 plus 3 times 2. Well, 2 plus 3 is just 5, so that's 5 times 2, or 10. Now let's do the times first. So I'll put the parens around that. 2 plus 3 times 2. Well, 3 times 2 is 6, and 2 plus 6 is 8, an entirely different number. So anytime you start to do something that has more than one operation, it's usually a good idea to put in parentheses. Now, you technically don't always have to. Processing has a built-in list of the order in which it will apply these operations if you don't give it the parentheses. But I find the parentheses are so helpful for just looking at the code and seeing in a glance what is happening that I almost always use them, even when technically you wouldn't have to. The nice thing is the parentheses absolutely do not slow down your code at all, and they just take up 2 characters. They're so useful that I almost always use them, and I recommend them very strongly to you. So let's use parentheses doing something. Let's suppose that we have 4 grapes. Okay, we're going to create a counter. I'll call it numGrapes, and I'll give it the value 4. Now we add 2 more grapes. So somebody gives us 2 more grapes, no trouble. We know what to say. numGrapes equals numGrapes plus 2. Now, suppose we triple the number of grapes. For whatever reason, someone says triple the number of grapes you have. A new supply comes in from the warehouse. So, okay, we have 3 times the number of grapes. We go into our little expression there at the bottom, and I just add a times 3 in there. Uh-oh. Anytime you see pluses and times and all these things coexisting without parentheses, it should raise a little warning flag in your head, and you should wonder, what is that really going to evaluate to? Well, if we just count the number of grapes that are up at the top of the screen, there are 18 of them. So what we wanted was to take num grapes, add 2, and multiply that by 3. But the computer might do that, or it might do the multiplication first. So let's see what the two ways are the processing could evaluate this expression. Tell you what, I'm just going to get rid of the pictures now. I'll just type in the two lines we have. Num grapes equals 4, num grapes equals num grapes plus 2 times 3. For no good reason, let's assume that the plus goes first. So let's take a look at that. The computer says, I'm going to do the plus first. It's the same thing as if you had written this, with the parentheses saying, do what's in here. Well, num grapes has the value 4, so this is the same as 4 plus 2 times 3, or 6 times 3, or 18, which is the number we had in the picture. The other order processing could do it in is to do the multiplication first, in effect as if you had typed it this way. Well, what is this? Num grapes is 4. So that's 4 plus the quantity 2 times 3. 2 times 3 is 6. 4 plus 6 is 10. And that's the wrong answer. That's not the one we had in mind. We wanted to add 2 and then multiply by 3. So this is the one we wanted. And we tell the computer, do the plus first by putting the parens around num grapes plus 2. So in a nutshell, this is what we have to work with. We can add, subtract, multiply, and divide, and we organize our operations by using the parentheses. Let's see this in one more example. Let's go back to the fruit stand, and suppose that we have 3 peaches, and we want to keep them in our inventory. So we create a new variable called num peaches, and assign it the value 3. And we have a very well-stocked fruit stand, so we have 2 plums, and we create a new variable called num plums, and give it the value 2. Now we want to know how many fruits we have total in our fruit stand. So we create a new variable called num fruits, and we assign it the value num peaches plus num plums. In this case, it's 3 plus 2, or 5. Then someone comes up and says, you know what, in the back room, I found another plum. So we have to add 1 to the number of plums we have on display. Well, we know how to do that. We write num plums equals num plums plus 1. Now, remember that we don't have to type an int at the beginning of this line. You only need to tell processing that num plums is an integer once at the very beginning. In fact, it doesn't even let you say it again. It'll give you an error. It will say, hey, I already know that this is an integer. Don't tell me again. So num plums has already been defined, so I can just use it. But we have a problem now, which is that num fruits is no longer synchronized with the total number of fruits on display. The last time we assigned to num fruits, it had the value 5. But now we have 6 fruits on display. So we have to update num fruits. And we do that by having another line that says num fruits equals num peaches plus num plums. Processing executes that. Now we have 3 plus 3, and we store the value 6. So this tells us how to use variables if we're just adding to them. Let's look at an example where we will also use multiply and parentheses. In this example, we'll build a brand new fruit stand, and we'll keep track of how much it would cost for someone to come in and buy out our entire stock. So, okay, we have a brand new fruit stand and we're selling kiwi fruit. So we keep track of how many we have. We start out small. We have 3 kiwis on hand. How much are we going to sell them for? Let's say $2 each. They're very expensive kiwi fruit. If someone walked in and said, I want to buy out your entire inventory, the cost to them would be the total price of the number of kiwis times the price per kiwi. In this case, it would be 3 times 2, or $6 to buy out our fruit stand. So we expand and we add plums to our lineup, and we buy 8 plums. And let's suppose that we're crazy and we're going to sell the plums for $3 each. Now how much would it cost for someone to buy out our entire inventory? Well, it's the total price of the kiwis plus the total price of the plums. So it's the number of kiwis times the price per kiwi plus the number of plums times the price per plum. And notice that I have put parentheses around those 2 sub-expressions and added them together. Now, this is a perfectly good line of processing. It's A-OK 100%, and nobody would blink an eye if you typed this. But you'll notice it's a pretty long line, and in fact, I had to switch to a smaller font to fit it on the screen. If this line falls off the right-hand side of your text editor, it's going to be a real hassle because it means you have to keep scrolling to see the whole line. And this is not by any means the longest line you could make. Suppose you were selling 10 different fruits. Then you'd have 10 of these little parenthetical expressions, and the line would be enormous. There are two general techniques for breaking up a line like this. The first one is to make little subtotals for each of the pieces. So in this case, I'll create a total for the kiwi cost, and it's a brand new little temporary variable. I'll create a total for the plums, and now total price is just the kiwi total plus the plum total. This approach is really useful if the little sub-expressions have a really sensible interpretation. If the little expressions are kind of hard to interpret, giving each one its own name can help make your code clearer to understand and easier to debug later. If you think something is going wrong, for example, with the price of the kiwis, you can print out the value of kiwi total and see if you're properly computing the price per kiwi. If you stuck it all in one big line, well, if there's an error somewhere in there, it might be a little bit harder to find it. So this is a trade-off where we have 3 short lines instead of 1 long line. And for some people, this trade-off is really attractive. I do it this way quite a bit. There's an alternative, which is even simpler. You simply take the line and break it up with white space. When you do this, I strongly recommend that you line up the start of the lines, the stuff to the right of the equal sign. And in this case, you can see that the open parens are stacked one under the other. Now the lines just happen to be the same length, and so the right parens stack up as well, but generally you want those opening parens to be stacked up one under the other by using tabs and spaces. Processing doesn't care. You could have any spaces in there or none. But for human readability, by doing it this way, it's much easier for you to see at a glance, hey, that's one long line that I broke up into 2 little pieces. And of course, there's a semicolon at the end of this line that you simply broke up with white space. Part of the power of using variables is that processing maintains some variables that change over time. By using one of those variables in our code and creating new variables that, for example, describe the location or color or size of shapes, we can cause all of those things to change over time, creating animation.